Yeah.
I am Amit. I would just be kind of setting the context of the talk and just coordinating or moderating the session, the discussion section prior to this.
We'll go live now, Amit.
Yep.
Oh, we are live.
We're
Okay.
live. Yep.
Yeah.
Okay. So hello everyone. Welcome to another session on privacy matters at Hasgeek. So I think I want to probably set a little bit of context of why we're doing privacy mode, this kind of set of conversations around privacy in under Hasgeek. We've been talking in India for a long time around data privacy and privacy related initiatives, and the privacy mode initially started as kind of this conversation around what would the digital privacy or the privacy law look like, right? And from there on, it's gone on from that small ambit to thinking about what the digital privacy law would look like to more broader around data privacy, much broader context, both in terms of personal data and non-personal data. And to what we're trying to do now with the privacy mode kind of set of conversations is really help get people in the industry, in research community, trying to talk about what are the challenges around these set of operational challenges, tactical challenges, strategic challenges around how organizations should be thinking about data, how they should be thinking about managing data, how should we be thinking about working in a data across the ecosystem. And this is really important for a lot of people who are being participants in the Hasgeek conferences or community, not only as technology product leaders, but also as product leaders or business leaders, right? And so we're now in like this privacy mode set of conversations around thinking about helping lay what I would say like an architecture or a conversation, or let's say a framework or vocabulary that everyone can start to talk around how we think about data and data probably in a much more decentralized manner than we do right now. And if none of you have joined, seen the previous talks, we've had 3 talks right now under privacy mode, which were really around this topic. So we had, Paul, Robert, and Philippe from Human Colossus Foundation talk around, let's say, the 4 layers of decentralized architecture. And we focused on 3 talks. One was decentralized semantics, while the one was decentralized authentication, and the third was around distributed data governance, right? And I think those kind of set kind of the vocabulary around a lot of these conversations that we want to continue and have, different people in the industry as well as business, as well as public policy start to think about how to do this. So today, we're going to deep dive into another aspect of this, which is going deeper into the semantics question around that, right? And so we already know the 2 hardest problems in computer sciences are, as they say, naming things and cache invalidation in some way, right? And how do we get names for things that are consistent, right? Persistent, persistent. How do we ensure that people can actually refer to it, people can identify it, people can say, this is what I named it, and this is what makes sense to name it. And if they say this is no longer the name, how do we invalidate it, right? And in sense, those are 2 hardest problems in computer science. Those are 2 hardest problems in managing data, right? And anybody who's managed data is like, how do I name things? How do I figure out this is the thing, what it is, right? As we in data science say, 80% of the job is cleaning the data. It's just basically what the same thing. How do we know what is a real object in the world? And as we think about these growing pools of data, data processing pipelines, the risk associated with holding data, maintaining data, cleaning data, we need to think about how we can manage this in a better way, right? And there are fundamental ideas around it. Some of that we covered in the previous talks around decentralized semantics and decentralized governance. And I think today we want to go deeper into one particular example of this, of how, distributed identity identifiers can be used as persistent identifiers with probably much more benefit than what we've seen. And to do that, we have Dr. Carly Huitema from University of Guelph, who's going to be taking us through. Let me put it as one of the cases or one of the applications around this topic, right? And I know Paul has talked about this topic in decentralized semantics, so maybe I'll get him to come on board and introduce Carly, maybe set the link from his conversation in case for people who have not watched this, and then we'll pass it on to Carly to kind of take us through her work around decentralized data ecosystem, especially focused on the agri-food side, and how maybe watch and learn a little bit of examples around that, right? So Paul, do you want to set it up and kind of, help people get the context to some of the people who may not have watched your nice conversation that we had in July around decentralized semantics?
Sure. Thanks, Amit. Yeah, just in a nutshell, I did a talk as part of the data governance and semantics series on decentralized semantics, what decentralized semantics ultimately does is it enables different task-specific objects to be controlled by different actors within an ecosystem, for example. So it's really about ensuring that all of the tasks are separated so that you can kind of integrate them into a semantic stack. And at the resolution side, when you're resolving a credential or a form or stuff like that, you can kind of do it fairly dynamically, within a multi-stakeholder governance framework underneath that. So I've been working with Carly quite closely. We're working together at University of Guelph and Human Colossus Foundation. So it gives me great pleasure to introduce Carly. Carly, as you mentioned, works at the University of Guelph, developing Agri-Food Data Canada, which is a distributed data ecosystem for agri-food research data. And the talk that Carly will be giving today is for the research identifier ecosystem, where a decentralized identifier is a persistent identifier with benefits. So just to kind of give you a brief overview of a decentralized identifier, that's a new type of identifier that enables verifiable decentralized authentication, if you like, and then if you like, persistent identifiers are things like, well, they're basically long-standing reference to a digital resource. So you can think of things like, DOIs, those sorts of things, or ORCIDs, those sorts of things, those would be considered persistent identifiers. So without further ado, I will hand over to Carly, and who will give the next talk as part of this fantastic series. Thanks, Carly, over to you.
Great, thank you. Hi, so I'm Carly Huitema, and I'm going to be talking today about the Research Identifier Ecosystem. And I hope to convince you that a DID is a PID with benefits. So this is work that is currently being developed. It's being incubated at the Trust Over IP Foundation, and it's informing my work in Agri-Food Data Canada at the University of Guelph. Now, in the research community, researchers need to be able to unambiguously identify objects. Now, single objects, such as which particular instrument was used for the measurements, or this particular data set was a result of these research activities, or methodologies, vocabularies. These are all things that could benefit by having an identifier. Now, we can take that idea even further because with the creation of compound objects. So we would have like a project compound object, where it would reference the people and the outputs and the funders that were all part of a particular project. We can do the same thing for publications. So a lot of research information is disseminated via a publication, which is a collection written by a set of authors. They'll describe the methodology, maybe any code that's used, instruments that were used, the data sets that were generated. And this can all be expressed as a single object. Example. And finally, versioned objects are another example of things like you could have a publication and version 1, version 2, version 3, etc. So it can all be called the same thing, but you can follow the history along. Now, when we're able to identify these research objects, we can link them together via the metadata. So in the figure example here from Project Freya, we know that A and B are related and B and C are related, and therefore we can assert the relationship between A and C because of something that we call in research the PID graph. So a PID graph is that that we can view a network of the relationship between objects that are generated in research. So here we can see A, B, and C in that example, and I've extended the graph. And by following the graph, the idea is that we can jump from, say, a person to their paper and their methodology, finding therefore a related paper and related data sets, so traversing the PID graph. And there are many benefits to being able to do this. We can generate insight about the research that is being done. We can follow funding to see, you know, after this funding thing, these were the objects that were generated. Finding out what the community values, the thing that the communities reference constantly, or to explore new relationships. To be able to find new collaborators who might be working on related topics, discover new objects for research, like a new data set, and assemble new sets of related things, and ultimately perhaps to identify gaps in knowledge. So to uniquely identify the object, to find the description of the object, and ultimately trust the result. In research, what we need is a globally unique identifier that's globally resolvable to something useful and within a secure ecosystem. And in research, we call these things PIDs, Persistent Identifiers. Now, the current state of PIDs is that we have an identifier such as ROR or RAID or DOI, and when you have that identifier, you plug it into a resolver, which then usually searches some kind of database to find the unique record, and from the record you can then find the metadata and associated links that were originally associated with that identifier. So in this kind of system of current state, what you need is you need a centralized database, you have centralized control of that. In the majority of persistent identifiers, there's a predetermined schema choice, and there's really limits about what can be identified. So if we want to get to that state of the PID graph, to be able to unambiguously connect from object to object, we need to be able to describe many different types of objects. Now, I'm proposing here a new improvement for persistent identifiers, and that is the idea of decentralized identifiers. This is a new concept that's being developed. You can see that many of the persistent identifier pieces are here, but they're just rearranged. We still have an identifier, and that is resolved. We use a resolving service to find the record that's associated with the identifier. But here, for example, we can have those records on some kind of distributed ledger. And then ultimately, we're pulling out the associated metadata and any links that are related to the object that we are referencing. Now, there's many benefits to having this kind of system of decentralization. We have a robust decentralized network. There's transparency, trust, traceability. And with that traceability and the associated digital signatures, we have auditability. And that means that it's a very extensible system. And there's lots of opportunity here for innovation. So people can create new things in the ecosystem while maintaining high trust. And this is very key in that it's a governed ecosystem. Certainly in the research identifier world, we're talking about, we would be looking at building a system that is extremely governed and that is yet to be established. That would involve many stakeholders, and the governance is going to ask, like, how much of the ecosystem is directly governed and how much is open. Who, for example, is allowed to write different schemas? Who's allowed to register identifiers? Perhaps the ecosystem might want to limit where the identifiers can resolve to, or the role of endorsements. And all of these choices can be tweaked, because one of the key points is the funding model. So often funding is at a national level, but the need for a global system of resolvable identifiers is an international one. So governance is going to have all kinds of choices to be made about who can join, delegation, etc. And this is ultimately going to dictate the functionality of the distributed identifier ecosystem. Now, what about trust? How does trust work in this system? So how do we trust the results? In the current state, what we do is we trust the centralized authority who controls the records in the database. So you have a number of people who are privileged to be able to log in and are allowed to edit records in the database, and we trust that the centralized authority has vetted these. Now, in decentralized systems, such as the DID system, we have trust that's built on asymmetric cryptography. So asymmetric cryptography relies on keys. Anyone can independently create a private/public key pair, and then when you sign an identifier with a private key, you can mathematically confirm that signature using the public key that's available. So conceivably, anyone can create and sign identifiers, but no one can create an identifier with your signature. So we have a new way to trust. So we're moving beyond the idea of passwords and central authorities who do the vetting to private keys in digital wallets with the public keys that are available on the ledger. So the basic parts of the ecosystem for decentralized identifiers that I'm describing here, first thing that we're going to have is what we call the DID document. That's the object that's signed by the creator, and it represents the object. It's going to be the one that has the links to downstream resources, like the associated metadata of the object, the URL of where you can find the database, etc. And the location of this DID document, in this example, it's on a distributed ledger. Now, the W3C is a definition of decentralized identifiers. Of course, there's different ways that you can store this kind of information. And the DID itself is just a short little string. I've given an example here of a made-up research identifier, and that would be kind of the text that you might include with in your publication. For example, you could say that the data set is available at DID, res, etc. And then when somebody looks up that DID, they would then plug it into a resolving service in order to then compile the DID document and then trace it back to find the metadata and any external links. And all of this, of course, is predicated on private public keys. So it also involves wallets for all the users holding their private keys, and also possibly something I haven't mentioned yet, verified credentials, which might be credentials that let you do certain things within the ecosystem. So let's test out some of the use cases and illustrate the possibilities in research identifiers. One of the first things we're going to ask about is interoperability with existing systems. So we can use this decentralized identifier to point to an existing identifier. So my object already has a PID in this example. It's got, say, a DOI for a paper or something. So I can create a DID that just resolves to the PID. And it will be cryptographically signed by me so that anyone can confirm that I was the person who authored and controls that. So we see here the first thing that I do is I create my public-private key pair. I've got my private key in my wallet, and I would publish my public key onto the ledger of the decentralized identifier ecosystem. So that would say, like, Carly Heidema, I claim this to be me, and this is my public key, so that when you find something, you can check it and confirm that I was indeed the person who authored the author. Now, the next thing that I would do is I would create the DID for my paper that's already existing, and the DID would just be a reference downstream to the existing DOI or URL, etc. And I would sign that DID with my private key. So somebody else then would be able to go and look up that that they can confirm looking at my public key that I was indeed the author of that paper DID. And the important thing here is that I didn't need a central authority in order to secure and trust my decentralized identifier. So coming back to one of the key ideas that I introduced at the beginning of the talk, the idea of creating different types of identifiers. Currently, in the systems that we have right now, it's hard to do. So what we ultimately have is that, you know, if we want to create an identifier for a person, then we have to have international collaboration. They'll write about what kind of information belongs with this identifier. Then in this example, it's known in research as an ORCID ID or ORCID, and they will run their own database that has all the entries. And then we come along and we say, no, now what we'd like to do is collections, projects. So the RAID identifier gets international collaboration, and they set up a database, they build a resolver, they secure the funding, etc. So you can see that it's as it is currently being used, as it currently exists, it's difficult for new types of identifiers to be spun up. So we don't see a whole lot of adoption of the different types of identifiers. But if we go back to that figure of the PID graph and being able to follow resources, we can see that it would be really beneficial to be able to give things unique identifiers and describe them with the appropriate metadata. So with the decentralized identifier ecosystem, it can be very easy to create a new identifier type in the system and to have the high amount of trust that goes with it. So another example of a use case, so I am the Canadian Society of Microbiologists, and my my membership has identified a need. We want to create a new microbiome identifier type so that people can give their microbiome research objects, like a sample, a decentralized identifier, and they can describe it using this new community schema. So in this example, then, here's a different variation of governance. So perhaps the governing body says, grants the CSM an organization their credential that grants them the right to publish schemas in the ecosystem. So maybe in this kind of governance model, we say that schemas are only allowed to be registered by specific parties that have been granted that right. So what the CSM does is they are going to, because they have the permission for it, they're going to write a schema, and then they're going to create a decentralized identifier that points to that schema, and they're going to publish that on the, they're going to publish their DID document, and they're going to sign it with their private cryptographic. Now, let's use that new microbiome schema, and we're going to mint a new identifier. So Alice, she has a microbiome freezer sample. She's been attending. She's a member of, say, Canadian Society for Microbiologists, or she just appreciates their work, and she wants to give it, she wants to give her freezer sample an identifier, and she wants to describe it using the CSM microbiome schema. So the first thing that Alice needs to do is that she goes out and she finds the CSM microbiome schema. Perhaps on the CSM webpage, they have published a list of schemas that they support or endorse or that they are authors of. And that's maybe the way that she enters into this ecosystem. She's found the identifier for the schema. She looks it up, and she can confirm that the CSM were the ones that digitally signed the schema DID, and she trusts that she has found the correct schema because she looks at the CSM, their decentralized identifier, she looks at the who signed the schema, and she confirms that it was them, and then she is able to go follow the links and find the actual schema. So now what Alice is going to do is she's going to write metadata for descriptive data, metadata for her sample that she wants to give an identifier to. So she composes that metadata according to the schema that she had found. She's going to reference the schema that she's using in order to write that metadata. And then she is going to create an identifier for the metadata record that she has just written. And she's going to assign that identifier with her private key so that anyone can look up and confirm that, yes, it was indeed Alice who wrote that, who authored that microbiome sample, and she was the one who registered the decentralized identifier. So another use case that we can talk about is the ability to create a compound object using a schema and have that compound object reference other identifiers. So for example, we find the schema for a publication object, and it will say that you need to contain different features like who are the authors, data sets, etc. So you can write that metadata for the publication and then give it an identifier so that people can find that publication. And then that publication itself can internally say, oh, the authors were then referencing the specific author DIDs or PIDs or something, and the data set identifiers as well. So you can write compound objects and they can contain references to other objects. So with this system, we have interoperability with existing systems of identifiers. So it's very easy to add new functionalities. It means that we can create a flexible system that enables creativity. We can have researchers controlling different aspects of the ecosystem that they are able to build. And since everything is signed, there's going to be full provenance. And this should ultimately handle enhanced reproducibility in science. And in my little examples here, there's a lot more of the technology that there is than what I have discussed, like open wallets, key management, carry, for those in the know, revocation lists, endorsements, licenses, and so on. But the next step after all of the discussion here would be to start making governance decisions about all the different parts that are possible, how to put them together in order to make an ecosystem of research identifiers. Now, the technologies that I'm talking about here, parts of this ecosystem are being built right now. Now, I'm not the first person to come up with the idea that decentralized identifiers are great examples of PIDs in research. I didn't see this, but Marcus Sabadello presented Kalia Young's work at the 2019 PIDapalooza. PIDapalooza is a conference about research identifiers, and I guess they needed to make the topic that is admittedly a little dry a bit more interesting. So this figure is from Marcus's presentation, where he compared decentralized identifiers to all kinds of other identifiers that are currently being used. And I added in here that indeed the DIDs are unique for being the ones that are cryptographically verifiable. Another example of some of the technology being in use right now is that of GLIFE, Global Legal Identifier Foundation. So they are using authentic chain data containers based on carry. And in this example, GLIFE is a root of trust for identity. So these are, after the 2008 financial crisis, GLIFE was an organization that was founded in order to give all business organizations identifiers to help make financial transactions more assured. So they are now setting up ways to do this with cryptographic verifiable LEIs, legal identifiers. And here in Canada, we have the starts of another decentralized identity ecosystem. So some of the provinces are contributing to a Canadian hyperledger indie network called Candy. The idea is that Canadian government entities can be given identifiers, and they will be able to issue and digitally sign verified credentials. And the governance for this is available, readable on GitHub. The link is down below. So you can see some of the efforts that are currently being done with different parts of the tools for the ecosystem of persistent identifiers. And as I said before, the W3C They have, now recommended officially DIDs and VCs. Canada is also looking towards digital trust and identity and is certainly referencing these standards as well. So I hope that I have convinced everyone here that DIDs are indeed PIDs with benefits. Benefits are robust decentralized network, transparency, trust, and traceability. Everything is digitally signed. So this means that we have the possibilities for auditability, very flexible, all the components can be remixed, extensible to new use cases, and ultimately an opportunity for more decentralized innovation. I really like this ecosystem and the technologies that are part of it, because it means that we can start to become a bit more creative with how things get mixed. People can create new things within the ecosystem, but then they're still able to maintain a high degree of trust. Thank you very much.
Great. Excellent. So, Kali, that was really, really illuminating to hear you talk about PIDs and things with benefits. We obviously have a set of people who probably would have questions around kind of the cases and going deeper into this. So that's kind of the conversation that we want to go more on it. But let me kickstart with maybe a question. And I think I kind of posed this to Paul also earlier, in the sense of, the W3C, has been trying to do the decentralized IDs for a long time, right? Federated IDs was before that. And we've tried schema.orgs and, many different ways that were initially tried to make the semantic web. So the URL itself as kind of the, let's call it not verifiable. In your diagram, it was not persistent. It was outside the diagram as a domain name. And I'm trying to think about how much time it has taken us to build that infrastructure. And is there a way that we can build on this, or we have to recreate the entire governance for each and every identifier we create, right? Because it does sound like now we have new URLs, and I'm calling them URLs, but it's like did : let me call it Amit caps, like my personal : something, which just sounds like I have a new URL, universal resource locator, which is maybe cryptographically verifiable. But everyone has to get to do this again, right? Like every ecosystem has to decide who's the governance, who is to do that. And the web already is decentralized and has a lot of this certificate transparency on all of that. So I'm trying to figure out, is there a way we can speed up that process, or combine that we leverage the URIs also as DIDs, or is there a way to merge that rather than getting this governance going again around each one of them, which is taking a long time to even work right now, right? So I don't know. This was my thought.
Yeah, I mean, the challenge is that like the thing with the persistent identifiers is that the current structure of the web doesn't meet it's not meeting those requirements. So we can definitely leverage some of the technologies and stuff like that. But I agree, there is a new paradigm, and there's going to be work and investment. Personally, for example, I'm really sick of passwords and the 50 million passwords that I have for different websites, and then you go to federated ID, which is someone else controls all your passwords. Right. And then if you disagree with someone else, then all of a sudden you lose access to everything. So this is the current system, and those are the current risks. And I would like personally to see the locus of control come back into my hands. And what the technologies are trying to build is that you wouldn't have to manage this so well. You would be managing a wallet, and your agent would be the one that was keeping track of all the decentralized identifiers, and I'm not going to get into recovery of and quorum and sharding, and there's lots of neat things there. And then as far as for research identifiers specifically, like I know that I have seen like trying to push out new ideas of sample identifiers, and it's just the uptake is so slow that, you know, because each time it needs to be recreated independently. So yeah, so you know, I'd like to see in instead of it being done one at a time, to be done to build a system in which then you can recreate or build new things without having to build a whole new ecosystem each time. Right. But like URLs, I mean, in research, persistent identifiers were built to replace the challenge of URLs, because every time a web page, every time a journal article rearranged their internal structure, their URLs would all change, then all the references to those papers were lost. So the PIDs were created to add some persistence so that you could change the underlying URL.
Right. Okay. Okay, so I'm gonna, Samir, Ramesh, you know, if you want to come along and ask Carly some questions, you know, please join. While they come on, would I be able to create a DID? Can I like start my own DID? Can I just say I'm interested in, you know, eclectic books, and I don't care about ISBN and, you know, DOIs, and I want to class my DID : eclectic books : something. And I want to build my own community. It's decentralized. Should I be able to go somewhere, register, and start doing this? Or is it going to be large institutions who are going to capture this authority to create schemas and manage this, which is like decentralized, but really not decentralized?
Yeah, well, what I would really like to see is the interoperability. So that would be like today with a website. It's decentralized, but centralized in the sense that, you know, I can pick up my web page and I can change my server location. I can go to a different hosting place, and I can then update the persistent identifier, that is the DNS, that would then point to a new location.
Correct.
So there, so this idea is not unprecedented, but if you were, when you talk about a DID, or do you mean the ability to write your, because you can play in someone else's ecosystem and using their ecosystem, you know, say research identifier ecosystem went this way and eclectic books was then a schema. So you would have create a schema for eclectic books, and then you would have the permission in order to, depending on how public things are, the permission to write an eclectic book entry following the eclectic book schema. I mean, that depends on how open this ecosystem is. And then of course, there could be other ecosystems that are more public or more private. And now we get into the current construction of universal DID resolvers that are being created as well. So it's right now things are definitely in flux. There's opportunity here to make the world into, you know, thinking about the long-term future of how we want things to be. Because in academia, for example, we have carved off a very key point, a very key piece of infrastructure. Publications are managed by commercial companies of journals, and all of reputation and knowledge translate or sharing happens, leaves academia, goes into commercial. And so we all of course see this whenever you try and go and a journal article is locked and stuff like that. So it is a self-sustaining piece of infrastructure. which is, one of the goals that people always say, but it's also quite a hindrance to academia. So building the ecosystem now means that we can start to think about, what are the cost trade-offs we can see in the future.
So, let me build on that. And Samir has this question, which I think kind of leads on to where you were pointing to, right? Like, I want to build a common pool of knowledge, or I as an organization. So forget like eclectic books. Now we're doing, let's say, public pedestrian traffic, or I want to do mapping of Bangalore, or mapping, and I want to create that data sets and some persistent identifier. And I want to get two things right? I want to create some data and get credit for it, which is like, I created this schema, I created this data, I've signed it, I'm getting the ownership. I also want to share it with other people, hence the decentralized ledgers. And so I get the rights and retain kind of the rights and credits for the work, pretty similar to what, academic journal example that you gave. But then I also enable it to share it. Now, but the sharing part, I mean, can you talk about use cases, or how do you see that manifesting? Is it going to be a lot more like, again, people who consolidate and manage this graph of PIDs, who would be, the analytics player or the search provider on this graph, who would say, we can look through all this Bangalore data or your journals data and graph and give you the search, and then we kind of are again not the publisher, but maybe now the analytics or the search engine on top of these DIDs that manifest it. And I think I'm always curious to understand this economic incentive that comes in on this layer, and how that impacts both this kind of decentralized, but also how people access this decentralized work, right? So maybe a few more cases that you think, real cases that would be good to build on. Was it clear, or am I?
Yeah.
The question?
Yeah. So let me start anyway. So first of all, with the identifier ecosystem that I'm talking about, we're going to keep it simple. It's going to do one function. It's going to link an identifier with whatever you want to stick at the other end. So there is the data itself is not controlled by the controllers of the ecosystem, of the identifier ecosystem.
Right.
So you could, for example, you can have, you can put a data set up, and you can say, I'm going to give it a DID identifier, and you can also give it a DOI identifier, and in fact, within DIDs, the DID specification, you could say also known as, and give other persistent identifiers that data set is known as. And so first off, there's no ownership associated with the data sets. It's just a pointer system. I think, but the advantage or the possibilities compared to the existing pointer systems is that you can start to add this cryptographic trust. So and also, it's not, it's decentralized, which means that countries can cooperate, and they don't have to trust, oh, all of our identifiers are on the server in this country, or, in the server in Ukraine. And now all of a sudden we have a massive critical infrastructure piece that's being threatened.
Right.
So that kind of decentralization is an opportunity. And I'm not getting into a whole bunch of downstream use cases, but right now the challenge with authentication or an opportunity within authentication is to manage these private public keys. And like, for example, I use DocuSign, I think, to sign a house, some deed or something like that, and I have no idea where those keys are.
Yeah.
Like, does DocuSign, I mean, I haven't taken the time to dig into it because I was, in a rush and it was done and stuff like that. But where are those keys, and can I see them? And if I change computers, have I lost my signature? And do I trust DocuSign to maintain their central registry? And can I go in and confirm that it hasn't been edited or changed or something like that? So by the similar, So the ecosystem doesn't exist, but I would think it would be very important for all of that information to be publicly available, even if not everyone in the public can write to all parts of it or whatever. And of course, then just as the web pages are publicly available, that means it's a data source for others to write, some kind of data crawler in order to, construct these PID graphs, to construct artificial, like to look through to say, oh, here are this schema XYZ, and here are the 500 data sets that are using schema XYZ. And we've looked up all that information on this registry where the DIDs are registered. So we can construct a virtual data set that references the 500 data sets that are all using the same schema. Doesn't mean that you have access to all of them. You just have their locations. And then this is part of what we're considering at Agri-Food Data Canada at the University of Guelph is then, how can we smooth with machine actionable governance the access to data sets, et cetera.
So I think let me take Steve's question here, because he's posted it on the chat. Individuals can create their own DID without permission from anyone. So that's great. But if that is as far as it goes, then it's not very interesting. Building a valuable community around, he's taking my example of eclectic books, for example, is the hard part, right? Mm-hmm. And I'm also curious on this, right? Like I'm trying to think of, nobody wanted to create schemas or semantics for the web pages, right? And the only reason everyone started to create it is because the crawlers, the Googles and the Yahoos and all of them started to say, or the Facebooks and the Twitter started to say, have this open graph, have this schema, have this DIDs, and then we will do the crawling. And right now it's not persistent, but they are still, let's say, extracting the data and creating some a graph, like you're saying in the IDs, and creating it, right? So building that valuable community around that is hard. Like forcing people to start using that is the hard part. That's what I guess he's kind of referring to, like getting enough people to use it, and the economic incentive of advertising or making my web page accessible was enough to push a lot of people to start putting in a little bit of semantics on the web page, not too much, but enough for the crawler to work. And I guess the question is, how do you create these communities around these schemas or DIDs that make them sufficient enough that everybody starts using it and starts to make it work? And I can also see Paul has raised his hand. So Paul, do you want to answer that question, or do you want to take a stab at it?
Yes, sure.
Yes. Go ahead.
I think the important thing is to differentiate between identifiers that are events and identifiers that are objects. And what I mean by an event is, when you enter information into a system, that needs to be verifiable that it's come from an authentic source, and that process there is identified through an event identifier. So you can think of kind of decentralized or DIDs from the decentralized identity community as event identifiers. That's exactly what they do. They have to prove some kind of provenance of the data going into the system.
All right.
Whereas object identifiers are in a distributed data ecosystem, the underpinning of those identifiers needs to be deterministic, meaning that it's basically a hash of itself, right? So the identifier is a hash of whatever that object is, and the control, keeping those two things separate is really important. So the control comes from the DID space, whereas the everything in the semantic space is a unit of language, right? And so that's just making sure that that an object is deterministic. So if you kind of think of it that way, the control of objects can be determined by linking a verifiable credential to those objects, and the verifiable credential is where the control comes from, because in the semantic space there should be no control. It's all about deterministic objects. So I don't know if that helps at all, Amit, but it just kind of I just wanted kind of people to think about that a little bit. So when they talk about semantics and issuance and stuff, you don't necessarily need to be burning that issuance part into the schema. You can be basically linking those objects to a verifiable credential that proves that you are the controller of that object.
I think that definitely helps. So I mean, we're saying we're not embedding the schema part into the object itself. I mean, the link to the hash is the object, and the schema and everything is there. But the DID, because of this namespace thing that we're trying to do, is inherently creating, instead of .com.org.org, now we have DID:research, right? So that schema of event is, again, communities or sub-communities or ontology that people have created around topics. And I'm saying, so let's say I'm interested in eclectic books, and I create that eclectic books community or that schema, and then any object in that is probably of some eclectic look, but whether you can access it or not access it is separate. But at least you can get a map of all of that, right? But now, I guess that's what Steve's trying to question, is the hard part about this is getting enough people to start using eclectic group, like DID:eclectic books something. Until that happens, the efficacy of all of that is not really that great. Now, whether it can be generalized across a lot of these research things, that will be helpful. Obviously, if we all start using DIDs, then it doesn't matter. If I search for DID books versus eclectic books and all, I can start to do that. Yeah. But
so Amit, just to jump in there, these are really kind of governance issues, right? So when you have a multi-stakeholder governance within that space, the voting members, if you like, of that ecosystem, they need to be consensually agreeing to the schemas and stuff that they're using for their ecosystem, and they have to do that so that you can harmonize the data, because it's really difficult to search for data unless it's harmonized.
Can you share a couple of examples of governance models that have worked around both public gearing goods as well as private information sharing?
I see Carly can
just before we move on, I just wanted to jump in about Steve's talk again about the community, and that the research community is uniquely positioned because we already are an international group that is already using persistent identifiers. So, in your paper, when you write DOI, then you would write you might use DOIs for papers because that's the community standard, but then you have a sample or something else, and you would say, I organized my data according to schema did such and such. And that means that somebody else who's research, who is doing similar research says, somebody else has already done the work of writing the schema that has, the fields that I'm interested in. So then they write their paper and they say, I wrote it according to schema did such and such. And so within the research community, indeed, this is already practice, and the ways that we disseminate is through publications or talks or societies and stuff like that. So there already is indeed this persistent identifier, universal identifier, needs to be adopted. In research, it's going to be pasted onto an existing community system that already does stuff like that.
But it would be, so the difference would be now those DIDs for, instead of DOIs, would be probably verifiable. So you can say as an organization or as an author, this is my DOI, I confirm that, rather than getting a central authority to issue you a DOI, which is what maybe a publisher does, or a book I don't know enough about DOIs, but ISBN is issued by different books, different regulations in different countries. So
you have to those organizations then absorb the cost, and they charge it's like $1 or something like that for every DOI registrant. That's the funding model. And but the thing is that while the DOI system could be flexible for other digital objects, I don't see it being used that way. And usually there's a few large schemas that are being adopted that are only used for publications or mainly just what I see as publications. And with the way that we could build the DID infrastructure, we could make it so that it's much easier for individuals or groups to write schemas so that they can start cataloging the very specific things that they need.
So could you, share the example from like your work at agri-food, if that's kind of, or the Ontario example, like build a little light, because I think Sameer's question is really valid to, I think a lot of us maybe have blockers because we know what we do now, and we don't see enough examples, at least definitely in India, around how this could be done in a decentralized way. I mean, we have centralized databases for everything, including identity, and we understand that, but how could a decentralized thing, whether the example in agri-food or the Ontario example that you were, or the cross-province examples on public, I don't know what that topic is. Could you shed a little light on that? Could help people understand some of the use cases and connect to what they're doing and works.
Yeah. So, well, there's a lot in the technologies, but if I'm going to talk just about the persistent identifiers, these global identifiers, which is directly related to the talk, then so at Agri4Data Canada at Guelph, we're not looking at identifiers yet. That's this identifier work is my work, and it's informing some of the work at Guelph, and Guelph is looking at how well. So we were trying to come up yesterday with how to describe it, and the idea that we came up with, imagine if the web was centralized. So it'd be, somebody would manage a giant silo and say, oh, if you want to write a web page, everybody logs in to our web server, and everybody puts all their web pages on the same one, and we have all the rules for it, and so on. So this and there's a single place that serves up all the web pages of the web. So that's the centralized model, and there's efficiencies, but it's also a giant honeypot for risk, for attack. I remember one of the quotes. So in the European data space for research data, they talked about if they wanted to build a silo for all the research data in Europe, they would have trouble like cooling it and powering that kind of thing in a single location. So we can see the advantages of decentralization, where we have many silos. In the decentralized example, it would be the database of all these pointers, these decentralized identifiers, distributed through a series of nodes, just like in a ledger system, but for those not with the huge amount of proof of work. Not all ledgers are Bitcoin, and not all ledgers require huge amounts of electricity in order to solve puzzles. That's the game of mining, which is that not all ledgers are Bitcoin based. Right. So, something like this can operate much more efficiently because you're not using proof of work. You have cooperation and governance about the nodes that can participate on a global scale. And a real world example. So the system that I'm describing, the parts can be repurposed to a whole bunch of other stuff. Like a whole lot of other stuff. But specifically my example here of persistent identifiers, where you would want to, you would have some kind of global cooperation, or want to, start this to say that you can unequivocally identify something uniquely. So in one of our earlier discussions like that, like if you can have multiple organizations, and they all might want to call the same lake or the same well or the same field. They'll all have different names for it and stuff like that. So this becomes really difficult to communicate and describe and search in databases, and do merges, etc. So if you have a group that wants to share amongst yourselves and a single identifier, and you want to distribute that information, and so that each group can independently, upload and control the records that they are working in, then this is the kind of system that that could be adopted. But it's not, if you're just a one-off, if you're, if I'm running a shop and I have my warehouse and I have all my objects in my warehouse, I'm not going to make a big distributed system in order to give them persistent identifiers. I'm the old, it's where you have control between different parties, and they might have different incentives and stuff like that, but they've agreed on this one part, and they they globally don't have to argue about where it exactly is and who has the direct control, and so there's this flexibility of design in it. So that's
Steve shared a document. No, I think that's helpful, because now I think at least I'm getting some better ideas around where we could apply. And I think Steve's also on the chat shared a document which is a link of adoptions by different public sectors and private sectors around a lot of the ecosystem around all of these verifiable credentials, at least, and some of them are based on these ideas. So I think that's useful for everyone to look at. I think we will post that on the chat or in the resources also later on. And I think this cross-industry thing is really doing. I mean, given I have a little bit of background in retail or consumer products, or like the idea of barcodes, or scanning for food, or scanning passports and having same passport scanners across the world. I mean, those are identifiers globally agreed by different communities or different ecosystems for making something efficient. People passing through channels, or containers passing through, or food passing through a checkout counter. And those identifiers we all recognize, though they are still centralized and governed, and within that community. And I think this idea of a verifiable pointer, as you kind of verifiable pointer to a schema, that really helps kind of make some of these possibilities make better. Before I ask, so Samir, did that kind of pick up your question, or do you want to come on the mic and maybe ask a further question if that didn't clarify how you?
Thanks. It did help. Of course, as I'm imagining it, we were in fact discussing how these data sets could be decentralized. But I think then there are earlier battles of at least like a meta schema emerging, because like I was telling Zainab, the battle we are fighting right now is the not invented here syndrome across researchers and research orgs.
Okay.
So there are.
But do you want to give a little bit more background? Because I think Carly and maybe I also don't have enough of the, just share a little bit of background, and maybe how we could think about a DID in that context, or would it even work? Ignoring.
Yeah, so I can, so just to give you a quick background, this is data commons being imagined across people doing work with land use and land cover data sets across India. Conservationists, people working in water, people working on, the hydrogeology of a region, and so on and so forth.
Right.
There are very large pockets of data for specific geographies, sometimes deep, sometimes sparse. And the idea was to have like an India-wide view emerge from this. There's pockets of, there's layers of tools that can then exist on it and be accessible to anybody working on the field. So we're speaking to over half a dozen orgs trying to do this. Of course, the data exists in a variety of different forms and formats.
Right.
Sometimes very dense PDFs and nothing else. So it starts from there. But I can see how this would, because one of the questions we did run into is, especially when you're talking to research orgs, there is the question of who owns the data, right?
Right.
So we were discussing.
So who collected the land use data or the hydrology
Yes.
data or the mapping data, and like, how do I get credit for that work or the collection?
Yeah, credit is one part of it, but just like an identification of
Right.
where it is, because it's also a question of the source of the funding. The government has its own set of regulations and restrictions around it, where it can be used and where it may not be used. So you need to be able to trace it back. So it's essentially a question of being able to identify where it came from and being able to manage it using a set of rules. There's also, of course, other questions around the data qualification and other stuff, but that's slightly outside the purview here. And
do you see something like, like I'm sure in land mapping and all that, there are already DIDs or some kind, like, census blocks is the US thing, but in India, we have probably area demarcations and blocks. And those are like unique identifiers or something that can be used as persistent identifiers across that, and you want to then have different.
I think something like that will be needed, especially if it's distributed. I don't think getting away from that. Of course, before we have an agreement on what, like if we go with the government definition of blocks and stuff like that, you have administrative boundaries. But I don't even know if we can do it through one set of identifiers, or we actually need a variety of sets, because just getting different research orgs to agree on how they look at the map is proving quite challenging. Yes,
itself is a challenge. Yeah. I think so. I think, Carly, I don't know, maybe you have pointers on how you got. I mean, even in research, right? I don't think people have enough background on how DOI also emerged, or what are the ways to think of these decentralized identifiers and getting consensus around the schemas, or what will be acceptable to be saved in this DIDs, right? Is there a process around that you can help people think about, or lay some guidelines or pointers to that?
So schemas are excellent and not well used. I think that's in research data sets, and certainly when I was doing research myself, it's one-offs kind of thing. You're not really even aware of the standardization or the need to standardize, because you've got small measurements or something like that. But as we're talking about interdisciplinary research, trying to combine, now it's not enough about, just crop outputs. We want to know about crop outputs and ecosystem services at the same time, to more globally optimize things. It's becoming more important in order for data to become more interoperable. Now, with these, in fact, I think it's mainly, the schemas, there are the few schemas that we already use with persistent identifiers. Those are a very top-down prescribed. So, they'll have an open committee, presumably, and you can, however their governance structure is for membership, either you're contributing enough money or you are a volunteer, something like that. And then, and those are writing the few schemas that are currently in use for databases and like DOIs, and ORCIDs and whatnot. But the ability to add a new schema is very limited right now. Because as I said, you have to spin up a whole new system. And that's, I'm kind of, within the research field, my personal inclination, I can see the advantages of having top-down larger schemas so that we all work together and become very interoperable. I see practical limitations to that. And I really see working at it from the bottom up. So at Agri-Food Data Canada, we're looking at this from the bottom up. Of course, we support, top down, trying to set up global standards. But from bottom up, what that kind of looks like is that right now, my schema, when I do a data set, my schema is, and I say now more modern times, I would upload the data into a repository, and the schema would be paired with it. Now, when the schema and the schema and the data set are tied together in a single repository, that it's like it only belongs to one thing.
Correct.
And if what we can do is that, if you're uploading your data, put your schema alone, naked, in a public spot, so that others can, if they want to use your data or extend your data or like what you did, they can find that naked schema and apply it to their own data sets. So this bottom-up approach is about working with what you're already doing, and with Paul Knowles and Human Colossus, and what we're doing at Agri-Food Data Canada is that the annotations of the schema can be greatly improved for interoperability. And you can write mapping, crosswalking between schemas. So if I have a really well-published schema and group over here has another really well-published schema, and now we want to collaborate on a bigger project, at least with it being public and documented, we can write the crosswalks in order to be interoperable. I mean, in a perfect world, there would be the ideal schema that everybody in the world has already agreed to, and researchers are all.
I think everyone is very has their own view on how they want to map the data and how they want to. But I think this is really a great idea. I think because a lot of us think top down. How do I standardize and ensure everything is collected together in the same format? But I think what you suggested is that the schema is emergent, that different people can collect schemas in different ways, and they could all be part of the same thing with different schemas. And over time, we can even have transformers from one schema to another. We can have mappers to do that. As long as it's well documented, I know what is what. We can then over time emerge into a better schema gradually, right? Like semantic versioning to some extent is kind of that idea of saying nothing is perfect. We just have another version, which is maybe an improvement on that, and kind of build on that. Sorry, go ahead.
And also with these top level schemas, they might not work for everything, but maybe half of your schema can be mapped to something global. And the inflexibility, the reason that a researcher always moves on to the next thing is because research is at the edge of knowledge, and what's existing is not complete enough to answer the questions, right? So they're going to be writing new schemas because they're going to be like, hey, nobody has ever looked at this before. This part,
right?
So we've never incorporated this measurement, or I have a new instrument and now it does these 5 things. I think
this kind of brings really this good point, because I think in decentralized thinking, in centralized thinking, we think top down to a large extent, right? We start a committee and build everything. In decentralized, as in the emergent schema, I really like this word, emergent schema, as that emerges over time as more people work on that, is really valuable as a different way of thinking, which a lot of us don't really put on that hat without thinking decentralized first. Paul wants to say something on it. I am sure he has lots to say on this. Yes, Paul.
Yeah, no, something that also Carly and I have kind of briefly discussed is all of these kind of amazing ontologies that people have been working on for the past 15 years in certain ecosystems, and how you can use tagging objects to tag ontology terms to data capture structures that have been consensually agreed within a distributed data ecosystem. And one of the interesting things is by separating the semantics, you can actually give different actors different control of different objects. So for instance, like if you think about researchers putting schemas into a distributed data ecosystem, we don't care how they capture their data, right? It's they capture it however they want, but there are transformation overlays, which are separate objects, which can obviously cryptographically link to these structures. But when you talk about something like ontology tagging, it's interesting because usually the context would come from the source of the data. But in the case of ontology tagging, the only people that will be able to see all of the schemas within the ecosystem will be, some kind of subject matter experts or something within the data ecosystem. So within that governance space, you could have subject matter experts, ontologists, kind of, doing some of the more contextual mappings onto ontologies on an ongoing basis as the ontologies evolve, but also as the ecosystem of research for a purpose as that evolves. So I just wanted to kind of throw that out there. Something.
No, I think that's I think that's a really good point. And I think, Samir has this point on how do you write services and APIs on top of these kind of things. And, one of the ideas in distributed software is how schemas evolve and how schemas evolution has to be managed and how you can have translation logic from one schema to another. And one of the ideas that I shared, with this idea around lenses that help you manage distributed data schema evolution, and in our case, maybe multiple schemas at the same time and seeing what it is. I think these are interesting topics. People have been thinking about both from thinking about how to manage schema evolution, but also from a programmatic perspective, on a workflow perspective, how lenses or mappers can be used to go from version 1 to version 2 or multiple different versions at different levels of granularity. And to do that, and how far can you go, and where do you need to then stop around schema? Like you at some point say this is now the new schema, and everyone agrees. So you probably start with distributed stuff, then maybe the ecosystem comes down to maybe some common ideas that start to emerge, and then you kind of merge on that, and then you build another evolution there on that. I think this is I think for a lot of us, I don't know, a lot of us, but at least for me, working in large organizations or backgrounds, less so in public policy, we're more used to thinking in a very centralized way, right? Our databases, our persistent identifiers, our primary keys. And I think for a lot of us, it's how to do this decentralized effectively, both as identifiers and as well as the data behind it, and how to manage it is something that's, I think, a bigger challenge. And I'm generally talking about technology people that we in Hasgeek kind of see people coming in conferences. They're all like businesses focused on a lot of that public private thing. So I think it would really be great, Carly and Paul, if we maybe in one of the future's conversations bring a little bit of private people that have done it in a non-public policy area. Does that make sense? Non-government linked area, because I think it's easy for people to see it in a common good. Commons area, as Samir rightly pointed, commons, the tragedy of the commons, and we can all see the challenges and tragedy of the commons. But how can I make something that I'm doing in my own organization and still think in a decentralized way that will help other people to also benefit from it, is a lens that we all struggle with. And I think more that both of you can share examples or point people to how to do that, to just change their lenses around that would be really helpful. Does that make sense?
Yeah. Paul, if you have a good one. I'm thinking, coming from academia, of course, I'm always thinking through the lens of public good and stuff. One of the things, one example I can think of now is that carbon capture and carbon capture markets and stuff like that, because the multitude of ways that one would want to describe how much CO2, say, an activity has, and there's so many different activities. There's so many different ways to describe the carbon capture from those different activities. And in a private market where you want to be exchanging carbon credits and stuff, you would want to know the methodologies used to calculate the carbon that goes into the carbon credits, right? These aren't measured. They're calculated from algorithms with a certain set of data inputs, right? So I could see like the private sector would benefit by being able to publicly identify, that the methodology. So the methodology would be given an identifier. We could see who digitally signed it. So we could see perhaps there are, you could in a market, you could say, oh, we want to buy carbon credits, but the only ones we count are A, X, Y, and P. Because those methodologies have been well validated for our country, our business desires, etc.
Right. So, I think trust, like I think you rightly pointed out, I think trust, we haven't talked enough about it, but this factor of trust that comes from this verifiable identifier is something that is lacking right now in any kind of identifiers we have, right? And I think bringing that into the conversation could also provide the governance incentive and the economic incentive for a lot of people to think about adopting them. And I think when we talk more about the tech of it, I think the tech is the easy part. I know tech is not the easy part. I know tech is not the easy part, but the tech is the easy part. It's the governance and the economic incentive, which are the harder parts for a lot of the adoption style. And I think probably need to think about in our communication, like how we can do that more around these trusts, stuff that basically translates into easier governance, easier buying for organizations to do it. Or, I take the example of passkeys, right? Like, I mean, who would have thought that cryptographic sign-ins would start to become common? But now that, the big players have started to adopt, public-private keys as one of the methods to authenticate, we can see that there is an economic incentive. Everyone hates password. Everyone believes no trust, public key credentials is better, and adoption will happen. Well, maybe not now, but in another couple of years, hopefully, we will get away from passwords or move away from it as the primary method.
I was just going to jump in there and actually say that the model that we showed that I showed in the decentralized semantics regarding the master mouse model.
Correct.
So that's a fractal model. So it's quite. If I was to set up a new company tomorrow, I would just set it up in exactly the same structure as that. So basically, you always have new data coming into the system or into the organization, and you always have business insights people that are looking for data to improve their business. And then in between that, you kind of have what we call access management to the objects or whatever. So that model doesn't really change. I think. And obviously, as these distributed data ecosystems become the first few that go live, organizations that are kind of built upon that structure already can easily start integrating into the bigger picture.
But Paul, we are simple people. We struggle to see layers and fractals as easy as the first level. I fully get what you're saying. I'm just trying to say that it's harder to see that. I understand the layers, the fractals, the fact that everything can be we can go one level lower and start to see that same thing in action. But there are two things in companies that are really hard, right? I mean, or let's say just one thing, we can have a great distributed strategy, but our culture on how we think about it takes a longer time, and very few people are starting from scratch. right? So
Yeah.
as my consulting people would say, culture eats strategy for breakfast. And, how do we get people to start changing that culture, thinking that decentralized lens? How do we get trust, governance, and the economic incentives to do it? Sadly so. Is going to drive a lot of this conversation. The tech they will figure out. I'm sure they will buy into any tech that any schema systems. They will adapt anything as long as there's enough incentives and enough governance for them to do it. Right?
It's really interesting because, part of our kind of deep diving into all of these kind of conceptual pieces kind of showed us that some things that people, common terms that people are using are kind of a little bit outdated already. So, when you talk about IAM, identity and access management, identity and access are two totally different things, right? So identity is really, that's an IT job, right? That's about authentication, making sure that it's come from, everything can be provenance nicely. But the access management is totally different. That's more of a business decision. So that's, it needs business leaders to be authorizing people to do certain tasks, but it's very much more of a governance thing than obviously identity. So, but it's only by kind of going into this and separating things that you realize that some of these old terms in a distributed data ecosystem, they're very difficult to shoehorn in. You kind of have to separate those pieces.
And I think that's one of the challenges, because not everyone thinks in the distribution. Like, I don't know, I shouldn't say everyone. I cannot think naturally in a decentralized way, other than the web examples that I keep bringing, because that's the only one that I can think which is set up in a very decentralized way. Every organization ends up thinking much more in a very centralized way. And, I know the vocabulary is a challenge. The vocabulary is very grounded in the centralized way of thinking. And how do we shift that mindset in our communication, in our talks? And I think what will really help, and I'm just talking from our audience perspective, is really to see, more examples of, people blazing the path on this in a way that is being done, maybe not just for a public policy perspective, but also from a private policy perspective. I don't know if that kind of, those examples really bring it to light that this is possible, or open the lenses to, that there is another world. How do we get into it is the next question. But let me first see the other world, and how do we get people to open that blinders would be really useful.
Yep. I'm just reading Samir's comment here in Zoom about distributed data sets, for example. So, yeah, well, one thing with from a distributed system would be the idea of authentic data. In research, for example, at the start of the COVID pandemic, there were some studies that came out that promoted drugs and which had amazing results, and then they were kind of the truth travels much slower, and and then this discreditation of those research results, which were fraudulent. I mean, they were, in one of the examples, I think it was that, every 4 rows were copied with changes here and there. So once you actually got your hands on the raw data, you saw immediately that kind of stuff. Or things like, when they give their statistics, a group of 11 people, exactly 50% had this thing. And it can't be 50% when you have 11.
Right. Yeah.
Right. It has to be some, so these were the kinds of things that were indicative about inauthentic data, but they, with digital signatures and perhaps, even in the far future, when it comes off an instrument, the instrument digitally signs the results so that they cannot be, so that we can have provenance tracking and we can see where changes were and, and when that happened. I mean, the field of Alzheimer's research spent, I think, a decade chasing after, I can't remember, but it was a fraudulent paper, and there were billions of dollars and a decade of research that was spent chasing after this, original fraudulent paper.
Yeah.
So, authentic data is something that in science we trust, but we get caught, and eventually things come out, but it might take a while, and that's only, of course, in places that are under active investigation. If you're publishing the one-off thing for this one-off observation and nobody else really cares, it'll never be detected, unless somebody's going to pay for the reproducibility study.
Right.
So,
I think
so
who audits the auditors is kind of the traditional question around that. And
yes,
peer review provides that in the kind of, if the topic is important enough, other people are chasing it, and they'll eventually discover the truth.
Yeah.
And I think it's harder to do that in communities where that's not the norm, right? Like, I mean, journalism tries to do that in the public policy, like they're the fourth pillar of the democracy in some way, to try to observe and call out all of that. But how do we how can we all check the authenticity, verify it, and do that? And I'm hopeful. I'm hopeful, like, now that I'm getting a sense of all the stuff that Paul and you, Philippe, and everyone's been talking about, that it should become easier to do this across industries and across areas where we can think about data, we can think about the lineage of the data, we can understand the provenance of the data, we can trust it, or if we care enough, we can find enough resources to understand it and say whether it's correct or not correct, and even consolidate. What Sameer's asking, I get different data about air quality right now, for example, from different sources. How do I merge it together? How do I merge all of this together in a trustworthy way with different schemas? And all of that should become easier in this new world. I can't wait for this world to come. I hope it comes sooner than we are going right now. But I really look forward to it. And I think it's been really great. Carly, thank you so much for, spending the time, and, from Ontario. Thank you so much for getting up it's really early for you, coming onto this, recording the talk, and thank you also to Paul for, helping anchor this whole series and kind of helping us all build this decentralized vocabulary, which we sorely need. And I can't thank both of you enough. I look forward to seeing more of the work and more of these conversations, and hopefully we'll have many more of these continuing definitely on privacy mode here at Hasgeek. And I think for everyone else, we're nearly at the end of our time, so I'm gonna kind of close it. So if you want to follow, you can definitely go to hasgeek.com/privacy_mode or privacy mode, sorry, just privacy mode. And you can see this conversation, the previous talks, a lot of the other talks and other work around the privacy mode topic. There's also a Telegram group that you can join. You can find us from there on Twitter and continue this conversation. Carly, if people have questions for you, what's the best decentralized platform that they can reach you on? Or centralized, email, or Twitter, LinkedIn, whatever works for you.
Twitter and Gmail. So I'm a very much centralized person, but looking forward to.
What's your Twitter handle, just so that people can? Is there? Okay, I guess we'll put that. They can look it up. That sounds great. So you know where to. Okay. Yeah. So your name at Gmail is pretty much the Gmail, and Twitter we can find. Well, thank you so much. Thank you to you, and thank you, Paul. And I also want to thank Sameer and Steve, who've been asking all these questions around here. helping me stay online, ask the right questions. So thank you, Samir. Thank you, Steve. And Carly is on Twitter at microbiocarly. So if you want to, go follow her and ask more questions on PIDs and DIDs to her on that. Thank you, everyone, and hope you have a good rest of the day and a good evening to everyone in India, and a good rest of the day to both of you where you are. Thank you so much.
Thank you very much.
Thank you.
Thanks, Amit.
Bye.
Thanks.
Bye.